Hello, everyone. Welcome to Anuta Network's session. Today's topic is a case study for a financial services provider. They are delivering responsive networks with closed-loop automation. I'm Kiran Sirupa. The agenda for the next 10 minutes, I will walk you through the customer overview, a little bit about our company, and then we will discuss the Anuta's Atom solution. I have a few minutes of demo video, and then we will wrap up with some Q&A. Feel free to stop me for questions. So a little bit about the company, Anuta Networks. We are based in San Francisco Bay Area with customers and partners worldwide. Some of our leading customers, as you can see here, very large telcos and enterprise customers all over the world. And what we offer is called closed-loop automation that delivers orchestration, analytics, and telemetry for multi-vendor networks. We support 45 different vendors, and we orchestrate and automate networks across multiple domains, whether it's your data center, campus, branch, the MPLS core network, or the SD-WAN as well. So the case study today is about a financial services customer. They deliver financial news, stock data, as well as disclosure data to their customers. And their main challenge is about delivering this financial data within milliseconds to their customers. And their network engineers said, our network is a slave of the applications. Whatever the application wants, the network has to respond within milliseconds. So they want to implement a real-time network analytics, and they want to make the network very responsive to the application demands, and they want to do this within 500 milliseconds. So we'll go into details as how the Anuta's Atom is helping him deliver this demand from the applications. So a little bit more in detail, the requirements, right? The solution, the automation should be able to collect data, whether it's streaming telemetry or traditional SNMP-based data, and this all has to be analyzed and has to create reports and notifications within milliseconds. And this has to scale to thousands of devices and millions of enterprises, millions of interfaces, and this has to be stored for more than a year for compliance purposes. And they want to make sure the platform is fully redundant and there is no single point of failure, and this has to support open standards. So the solution we offer, I said, is closed-loop automation. It's best to explain using an example. Let's say you can define the baseline behavior for any network. Let's say you're looking at the interfaces. You can say, I don't expect this interface to flap more than 2 times in a day. Now, you can define what you mean by that metric and how you want to collect it and how frequently you want us to monitor it. And then the correlation engine is comparing the current behavior with the baseline behavior. And based on the various deviations that are happening, it can automate the corrective actions. So for example, if the interface is flapping once or twice in an hour, you can open it as a ticket in a ServiceNow system. But if it's like excessive flapping, then you can immediately shut down that interface. So we can introduce automatic remediation that works across multiple vendors using a workflow engine. And we can also integrate with tools like Grafana, so we can visualize all the metrics and generate reports and compliance reports as well. This is a bit a detailed slide. It tries to explain how we achieve this. The Atom platform is composed of many microservices. All of these are Docker containers. They provide individual functionality like discovering the devices, building the topology, collecting the telemetry data, creating a service chain across multiple vendor devices, as well as delivering analytics and visualization of the network infrastructure. We integrate with 45 different vendors, all the leading vendors, Cisco, Arista, F5, Citrix, Juniper, you name it, we have it. All the networking related devices, we can configure either using CLI, netconf, XML, API, or REST as well. And all of this data is stored in a time series database with which you can query the data and generate all kinds of reports. And we use Kubernetes to manage the various Docker containers within the Atom platform. So this can be deployed on-prem, or this can be deployed in public cloud like AWS and Azure as well. So here is the customer deployment. As you can see, it's a fully redundant design. They have multiple data centers. The Atoms, 2 instances of the Atom, they are synchronizing each other. The policy data, as well as the time series data, is constantly synchronized so that you have a fully redundant design. And we will go through a short demo of how this whole integration looks like. So let me switch to the demo. This is a recorded demo, so I'll try to pause it so you can follow along. So first, we are going to show a dashboard of all the devices. We then discover the devices. We can see the various devices, the config, and the Atom is sucking up all the configuration data from all these vendors, and it normalizes it into a JSON object. So now it builds a topology of your network. It creates this concept of resource pools, and you can look into details of each of the devices. As you can see, it overlays the operational data on top of this topology. So that gives you full visibility into your entire geographical distribution. And then we are configuring the telemetry data, the sensors. On this case, we are configuring the interface statistics metric on the Cisco iOS XR. You can you can decide exactly which data you want from this particular iOS. Here we are looking for interface statistics. And we can push this config across hundreds of devices. Now, from a single GUI, you are configuring the Arista, the Cisco, Juniper, and Atom will go through a workflow engine. It's going to now show you the model that it is going to push to the device. As an operator, you can look at the model and verify that everything is working correctly, and you can approve it and schedule to push this config at any particular time. So once it is approved, the Atom is going to auto-generate the commands for various devices, whether it's the Cisco or Arista or Juniper. As you can see, it's going to show you the Cisco CLI that is going to push to the devices. Now the device starts sending the telemetry data to the Atom platform, and you can see that data in the Grafana dashboard. So here, we collect various metrics like interface utilization, CPU utilization, interface drops, and things like that. This Grafana dashboard is highly customizable. You can build your own reports and have different alerts created out of it. And because this customer is so particular about the latency, we have collected the latency within the Atom platform. You can see that in milliseconds, in 26 milliseconds, we are able to take the network state, like something happened on the network, and that data will be stored in the database for applications to access within 25 milliseconds. That's the kind of latency we are dealing with. The Atom platform optimizes the overall end-to-end latency by using the latest software stack, and it works across multiple domains. So it's a really short demo. The main takeaway is that the Atom platform is able to meet the latency requirements and help the customer deliver very fast and responsive networks that are working across multiple vendors, and that has a very fully redundant design using open standards. So here is the final slide. As you can say, the Atom scales to millions of devices using microservices-based architecture. It introduces closed-loop automation that delivers analytics, remediation, monitoring, as well as orchestration for multi-vendor infrastructure. And it also can be deployed on-prem or in the public cloud like AWS and Azure. We have a demo booth over here, so please drop by, and you can check out the website for more case studies as well as data sheets. Thank you.